So whereas the first volume problems that we did, I love them. I'm like, this is a real life example. You can imagine creating a box. You have a certain amount of material. You want to maximize the volume and minimize the amount of material. That is a very realistic thing that businesses would want to do. This second word problem is an example of the most unrealistic word problem you could make up just to do math. Okay, like read this. Clara and 3 friends were born on March 11th. Okay, very probable. Leslie is 5 years younger than Clara. Mike is 2 years younger than Clara, and Thomas is 3 years older than Clara. This next sentence makes me laugh. Because in the end, you want to find out how old they are. In real life, you would go up to them and you would ask them, how old are you? Okay? In real life, no one would ever think of saying, oh, I happen to know that the product of their ages was 61,136 greater than the sum of their ages. Like, that is so realistic. It's like, I don't know how old they are, but I happen to know this other fact. I mean, it probably happens to you like 2 or 3 times a day that something like this comes up. So this is a bad word problem for being real life example, but it does, these word problems that are like this serve the purpose of just giving us something to solve. Other than that, they're not very good word problems. So I apologize to the author, but here we go. How old was Clara and each of her friends on that day? So to start off with, we need to create a variable. And this process is a good process of any word problem, because even in realistic word problems, you need to decide what are you going to set up as your variable. Everybody's compared to Clara. So I'm going to make Clara's age equal to X. Then based on that, we've got Leslie, Mike, and Thomas. And so if Clara is X and Leslie is 5 years younger, Leslie will be X minus 5. Mike is 2 years younger, he'll be X minus 2, and Thomas is 3 years older, he will be X plus 3. The next sentence, before I go to the algebra to put it in, I'm just going to think about it with words. Okay, the product was 61,136 greater than the sum. So that allows us to say we can make an equation. Well, that's a circle. We can make an equation that relates the product and the sum. But they're not equal to each other. The product is more than the sum. So if I want to add 61,136 to one side, does it make sense to make them equal? This is the side I have to add that 61,136 to, because the product is bigger than the sum. So if I wanted to make them equal, I would need to add something to the sum to make them the same. And now that we have this general idea of an equation, we can put the algebra in. What is the product? The product is all of their ages multiplied together. Equals, what is their sum? If I add these all up and combine like terms, can you see that I will get 4x minus 7 plus 3 minus 4? That'll be the sum. And then we still, in order to make these equal, have to have this on the other side. And now what we're going to do is look at different ways that we can use our graphing calculator to solve this. A non-graphing calculator way to solve this, we would have to multiply all those out. That would take a while. Some of you tried to do that with the question we did the other day. You found out it takes a while. Combine all your like terms, make it equal to 0, and then factor it, which could also take a very long time. So we're going to look at how we can use our graphing calculator to solve this. Method 1, we can type this side into y1, this side into y2, and find out where the two graphs cross. So let's try method 1. Go to our calculator, and x times x minus 5, x minus 2, x plus 3. And in y2, I'm going to have 4x plus, I'm going to combine those like terms, 6, 1, 1, 3, 2. Good? Now, most likely when you start, you'll be on your standard window, so this is what you'll see. Ooh. Oh. Ooh. And it's done. Okay, so we can see a little bit of the blue graph. We can see none of the red graph. What's happening here, if we look at our table of values, so now if you go to your table of values, you have a table of values of your blue graph and a table of values of your red graph. And you can see why you don't see anything of your red graph, because the values are all in the 61,000 range. So if we're using this method, what we need to do is set up our window so we can see both of them. When setting up the window, we have to use a little bit of common sense logic based on the question. We're figuring out people's ages. Ages are my x values. So when I go to my window, do I need to see negative ages? No. So I might start at -2 just to see my axes. When I'm thinking about possible ages that people could go up to, am I going to go up to 20,000? No. Right? I'd probably start with like, well, 100 seems like a lot. It's probably not even going to be close to 100, but I'll put in 100. And for our y max, we don't need to see negatives, but we noticed that we were in the 63,000 range. So maybe I'll go up to 65,000. My hope is that I'll be able to see both the blue graph and the red graph, and my hope is that I can see that they cross. It worked. So if both of them cross, your calculator has something built into it. Second, calculate number 5 where they intersect. Push enter once when it's on your first curve, push enter twice when it's on your second curve, push enter again, and it tells us that they intersect when x is 17. So on a quiz or a test, you could just explain that I put this into y1, this into y2. I found out where they intersected. I got x to be 17. So that means their ages are 17, 12, 15, and 20. We'll use this technique often. You set up your equation, put one part into y1, one part into y2, and find out where they intersect. The problem with this technique is that it sometimes is difficult to find out what window you need to use to see both of the graphs. And if you can't find the window where you can see both of the graphs, you're not going to have any chance of solving this. Another technique that is sometimes used is move everything over and make one side equal to 0. So I'm going to show you that next. So I'm going to delete clear out our second equation, and I'm going to say if I had this equation and I moved the other side over, that would mean I would have to subtract 4x on both sides, and I had plus 61, 132, so I'd also have to subtract 61, 132. And I'm going to go back to Zoom 6. So starting with a standard window, because this is how your graphing calculator is normally set up, you see the following graph. Wonderful. Wait for it. Oh, it's done. You see nothing. So it's just about as bad as before. But when you make one side equal to 0, what you're trying to find are x-intercepts. So again, this one sometimes people like it to as a little bit nicer, because if I go to my window and I want to see an x-intercept, I don't have to worry about my y-min and my y-max as long as I can see my x-axis. And so for my ages, I'll go from -2 to 100 again, and my hope is that I can find one x-intercept. Do you see that there's one there? Boom. That's all the graph that we're going to see. We have no idea what this graph really looks like, but that's what showed up. So if I want to find an x-intercept, that's also built into my calculator. It's under number 2, which is a 0. Now, in order to figure it out, you have to choose a value to the left of your x-intercept and a value to your right of your x-intercept. And since my x-intercept looks like it's at, well, we know it's at 17, but from 0 to 100, I would say it looks like it's around 20 if I was estimating that. So to the left of it, I might start with 10. Push enter. Sure enough, I was to the left. For a value to the right, I might make sure I choose 30. Perfect. And then when you push enter the third time, it finds out that it's 17 that way as well. So the nice thing about moving everything over and making it equal to 0 is that you know that you're going to be looking for an x-intercept, so that helps you with your window. I personally like what we did first with drawing both graphs, because when you move things over, you might make a mental math mistake when moving things over. I like to draw the intersection of the two. So your questions to practice with this one are 7 and 8.